earlier, we discussed to you the third level of measurement, which is the interval scale. Now, we will proceed to the fourth level and the last level of measurement, which is known as the ratio scale. Now, before we proceed to the ratio scale, let us have first this additional knowledge about, or let's say clarification about the interval scale. So, we said that interval scale, okay, we said earlier that the interval scale can measure, or let's say we can interpret the differences. Okay? Differences can be interpreted. Okay? However, the distances, are meaningless. Okay, let us have first the clarification on this one. So, whenever we say differences, these are actually the intervals. And when we say distances, this is actually how, okay, let's say, it states that how much a certain measurement greater or less than the other. Okay? So let us have this example once more. So let's say that we have a temperature measured in degrees Celsius. So we all know that when a temperature is measured in degrees Celsius, it can have negative values. Okay? And since it can have negative values, 0 is not the starting point. Meaning to say, interval scale uses the artificial 0. Now, let's say we have a temperature of 50 degrees Celsius and 75 degrees Celsius. And on the other setup, we have a temperature of, let's say, 25 degrees Celsius and let's say 50 degrees Celsius as well. Okay? So, if we will get the differences of this set, we can have a difference of 25 degrees Celsius. And when we find the difference of this set, we will also come up with a 25 degrees Celsius. Now, the difference can be interpreted, meaning to say, the difference between 50 degrees Celsius and 75 degrees Celsius is equal to the difference of 25 degrees Celsius and 50 degrees Celsius. Okay, that is what we mean by differences can be interpreted. However, we cannot say that, let's say 75 degrees Celsius, okay, we cannot say that it is, let's say it is let's say it is 1/2 times stronger, or this 1/2 times hotter. We cannot say that because we only measure the differences but not the distances. Okay? So the distances will be meaningless in the interval scale. Okay? It is meaningless in the interval scale because we cannot actually measure how much a certain measurement is greater than or less than the other. Now, let's say we have the temperature measured in Kelvin. Okay? So, temperature measured in Kelvin uses absolute 0. Meaning to say, 0 is the starting point and 0 indicates an absence of something. So, when we have 0 Kelvin, it means there is no temperature at all. Okay? So, let's say we have a temperature of 50 Kelvin, okay, and 25 Kelvin. Now, in this case, we can interpret the differences. We can say that 50 Kelvin, okay, is farther than 25 Kelvin because when you get the differences, it will give you a result of 25 Kelvin as well. Now, can we say that 50 Kelvin is times 2, or let's say twice as hot as 25 Kelvin? Of course, we can interpret that. And this interpretation will fall under the ratio scale. Okay? So, meaning to say, in ratio scale, so the characteristic of ratio scale is that, first, okay, the starting point is 0. Starting point is 0. And when the starting point is 0, meaning to say it uses absolute 0. Okay? So let us have another example. Let's say we have a length. So in this length, let's say we have 10 meters, 20 meters, and 30 meters. Now, we can say that the difference between 20 meters and 10 meters is 10 meters. And the difference between 20 meters and 30 meters is also 10 meters. Okay? We can conclude that. So, meaning to say, it has a property of interval scale because we measure the differences. However, can we say that 20 meter is twice as long than 10 meters? Or can we say that 30 meters is thrice as long as 10 meters? Of course, we can say that because, okay, let's have a computation. Let's say we have 10 meters multiplied by 2, it will be 20 meters. Meaning to say 20 meters is twice as long than 10 meters. Then, next, we have 10 meters times 3. It will give us a result of 30 meters. Meaning to say 30 meters is thrice as long as 10 meters. Why do we say so? Why can we measure this distances? Because in ratio scale, ratios are meaningful. Okay? Ratios are meaningful, meaning to say distances are meaningful. Why? Because the starting point is 0. Because if you use artificial 0, remember in artificial 0, the starting point is not 0. So let's say we have this example once more, 0 degrees Celsius, and let's say 25 degrees Celsius. And then we have negative 10 degrees Celsius. Can we say that negative 10 degrees Celsius is colder than 0 degrees Celsius just because of the fact that negative 10 degrees Celsius is 10 negative times more than 0 degrees Celsius? Of course, there is no such thing as that. So meaning to say, in interval scale, ratios are meaningless. However, in ratio scale, ratios are meaningful because distances can be measured. Okay? Distances can be measured. Okay? That is the main essence of the ratio scale. Now, if distances can be measured, if the differences can be measured in the ratio scale, meaning to say, the ratio scale has the property of the interval scale. Okay? Because we can measure the differences, the intervals between the numbers. Okay? Next, another one is that, okay, let's say in the ratio scale once more. Let's have this following example. Let's say we have a nominal value or nominal variable of height. Now, height can be arranged as short, okay, tall, taller, and tallest, right? Okay, now, using this scale of height, can we derive some possible values? Let's say short. Short, let's say we have 4'5". Then tall we have 5 feet. Then taller we have 5'5". Then tallest we have 6. Okay? So we have this kind of value. Now, can we say that 4'5", sorry, okay? Can we say that 4'5" is, let's say, has a distance away from 5 feet? Of course, there is. Now, 5 minus 4.5 is 0.5, meaning to say there is a 0.5 distance, as well as between this one and this one. There is a 0.5 distance. Okay? So meaning to say, it is 1/2 times more. Okay? So meaning to say, in ratio scale, we can have the property of interval scale. Now, what can we observe with this example? Observe that we used the term height, and we ordered the possible values of height. Now, did we use names? Obviously, we used the names. Okay? And did we arrange these names from least to most? Of course, obviously, we arranged the names as well. So meaning to say, the ratio scale has the property of interval scale, ordinal scale, and as well as the nominal scale. Okay? Now, if the ratio scale has the property of these three other levels of measurement, meaning to say, the ratio scale can also, what? It can also measure mean, median, and mode. Okay? Can measure mean, median, and mode. Okay? That is one advantage of the ratio scale. Now, okay? Now, if the ratio scale has the property of the three other levels of measurement, and it can measure the mean, median, and the mode. Okay? So meaning to say, ratio scale is what? Is it the weakest or the strongest among the four levels of measurement? So obviously, the ratio scale is the strongest. Okay? Among the four levels of measurement. It is the most reliable. It is the most valid. Okay? So this would be number 5. Okay? So this is number 4. Sorry. Okay? So that is characteristic number 5. Ratio scale is the strongest among the four levels of measurement. Okay? So something we forgot. In the ratio scale, we use numbers. Obviously, we use numbers. So meaning to say, it is quantitative in nature. Now, if it is quantitative in nature, meaning to say, ratio scale is a continuous variable. Okay? It is a continuous variable. Because we measured. Okay? We used measurements. And that measurement is in the form of the quantitative variable. Okay? So, that ends our discussion for the four levels of measurement. So to recap once more, we have the four levels of measurement. Number 1, we have the nominal scale, in which the nominal scale uses names. Okay, it uses names only. And since it uses names, it is a qualitative variable. All qualitative variables fall under the nominal scale. Now, the nominal scale is a discrete variable as well, and it can only measure the mode. Next, we have the ordinal scale for number 2. The ordinal scale uses qualitative variables arranged in a logical order. It can be from weakest to strongest, it can be from least to most, or it can be from greatest to smallest. Okay? It uses names, so meaning to say, it has the property of the nominal scale. It is a discrete variable as well. And it can measure mode and median only. So meaning to say, it is much stronger than the nominal scale. Next, we have the interval scale. In the interval scale, the intervals or the differences, okay, between numbers can be interpreted. Okay? However, the ratios are meaningless because it uses artificial zero. And artificial zero, meaning to say the zero indicates a presence of something. It can have negative values. Okay? So in the interval scale, we can measure the mean, median, and mode. So meaning to say, it is much powerful than the ordinal scale. However, it cannot measure the ratio. So meaning to say, it is less powerful than the ratio scale. Also, interval scale uses quantitative variables, which makes it use continuous variables. Now, last, we have the ratio scale. The ratio scale, meaning to say, the ratios are meaningful. The distances can be measured. It can be interpreted. The differences can also be interpreted because the starting point is 0. Why? Because when the starting point is 0, it uses absolute value. Absolute value or absolute zero means that zero indicates an absence of something. So for example, we have for examples of absolute zero, we have length, we have weight, okay? We have temperature in Kelvin, and we have test scores. Okay? So it indicates an absence of something for the absolute zero. And in the ratio scale, it can measure mean, median, and mode. And it uses quantitative and continuous variables, making it the strongest among the 4 levels of measurement. So this ends the discussion with regards to the 4 levels of measurement. Now, in proceeding with the topic of quantitative research, okay, since we are now done with the types of variables, okay, let us now proceed to the different methods of gathering data in quantitative research. And that will be introduced to you in our next video presentation.